Hey everyone, and welcome back to Data Idol Summer School. I'm Amy and I'm the Senior Events Coordinator for the Data Science Festival. The purpose of the Data Idol Summer School is for people transitioning into data or kickstarting their career. We have around 40 sessions running from August to October, which you can watch along with the community, and there is also a Slack channel which we will be popping the link into the chat during the session. If you'd prefer to watch it in your own time, this will also be an option which will be available from September onwards. I'd love to say a huge thank you to all of the Summer School partners that have made Summer School a reality this year, and a huge thank you to all of our speakers that have given up their time to support the data science community. I'd love to now introduce Deji, who will be presenting his session, Introduction to SQL. Thank you to everyone's support, and we hope you enjoy the session.
Hello and welcome to the Intro to SQL session. My name's Deji Olayinka and I'll be delivering this session. I'm a data engineer and I currently work at Mars, and I've been a data engineer for about a year or so, so I'm well understanding in the fact that a lot of you will be completely new to SQL, so I'm going to try and go through this introduction to SQL quite slowly at a good pace, and I'll be going over the basics of SQL, mainly select queries and the general basics of how to create tables, and also what SQL is as a language. I'll begin with some introductory slides on SQL as a language, but most of the session will be a live coding session, so don't worry about that if you're not a fan of presentations. So SQL stands for Structured Query Language, and it's basically a set of statements that you can use to access data in a database. Most applications that manage databases allow users to access the data using SQL directly, but some database systems also allow you to access them using other languages like Python. But many of those databases would tend to convert those commands from another language like Python into SQL before actually running them. Technically, SQL is a data sublanguage, and so it differs from other general purpose programming languages like C. SQL is really used to send logical operations to a database, and these logical operations make sense to us. It's really us saying, I want to select this data from this table, or I only want to select data with these qualities from this table. But then the database goes on to convert those logical operations into a physical operation to complete the task efficiently. So while us as users see the table as one object, the database might see it as several files with indexes on different columns spread over different hard drives. So there's a level of conversion from SQL into the actual physical plan that the database management system would use to extract that data. There are 6 types of SQL statements. The first is data query language. It does what it says on the tin. It's really about querying a database to select data into C and to ask, what data do you have in this table? What data do you have under these conditions? There's data definition language, which is really about creating and dropping objects, such as tables or databases or schemas, which I'll go on to in a second. Data manipulation language, which is really focused on adding data into tables or removing data from tables or modifying the data and you'll be using commands like insert, update, and delete to do that. There's also data control language, which is really about controlling who has access to what data, whether passwords required, anything like that. And data administration commands are really about running audits, and they're available on certain types of database management software systems. And finally, transaction control commands. These are focused on basically deciding whether an actual command gets completed, whether it gets rolled back and reversed, and managing how different commands compete with each other, or how different commands are handled. And that's something that a lot of administrators control, and also data engineers and people who are managing database systems. Now, I'm sure you know what a table is, but if not, I'm just going to go for a brief overview. But tables generally describe an entity, for example, a product. For example, you can have a table at a company that lists all of the products at that company, and what a database administrator or a database owner would do would define a table with a table name such as products, and give it a set of columns that relate to those products. So the example you can see at the bottom here is a table for products, and it's got the product name, color, the ID, the price, and so on. And each column would have a name, a data type, and some may have a width as well when you create the table. So the list price is it's a decimal, so that might be a float. The product ID is just an integer, and so is the product model ID, whereas the name and the color are strings, which is basically just text fields. And you might have different types of text fields. For instance, for color, you may limit it to only 10 characters, whereas for name, you might say up to 30 characters long. And you can see the example below. And within a table, obviously, you have a set of rows that go across, and a column which kind of link, and columns which link the attributes of those entities to the actual entity on each row. Within a database, you tend to get a hierarchy of objects, starting off with columns. Each table will have one or multiple columns, and within and what you might have is multiple tables that are related to each other, and they would form a schema. And so a company might have a schema based around its transactions, and that'll have like a products table, a invoice table, and an inventory table. And it also might have a schema based around the employees at that company, and that might focus on things like the employee's pay, their address, and other details, and they might form the same database system. And that's the logical data structure of a database. But the great thing about relational database management systems is that there's an independence between the physical data storage and the logical data structure. So different tables from different schemas might be on the same file system, and there might be a lot of crossover, and also a lot more spread than what you would imagine if you were to just look at the logical data structure. These schema objects are user created, so we define them and we make them usefully organized so that business people can understand where data would be and how they can interact with the database. Here I've got an example of the table from earlier alongside another table. And one interesting thing to point out here is that while you've got one table for the product, you've also got another table for the product category. And those two tables can be linked using the product category ID. What we call this is a foreign key. And in a lot of relational database systems, you'd have tables with foreign key columns that can be used to link to another table. And they would tend to be linked through the primary key, which tends to be the first column in a table. And it really is a unique key or sometimes non-unique key used to identify each of the rows. So here you have the product ID for each type of product, and here you have the product category ID for each type of product category. And that's basically what a primary key is. And here you can see this product category ID, when it's in this table, acts as a foreign key because you can link it to a foreign or a different table. Here you can basically see a larger schema, and you can see the link between the different tables on primary keys, foreign keys, and so on. And today we're going to be using the AdventureWorks database, which is a free to download database created by Microsoft that has a schema based around a fictional company called AdventureWorks. And it's easy to learn and understand SQL commands by just playing around with the data in this database. So I'm going to leave the presentation for now, and I'll return back later on. And we'll just hop into Microsoft SQL Server Management Studio, which is the software I'm going to be using today. It's basically a program that allows you to manage a SQL Server database. And to kind of bring you to your bearings, in this top area here, I'm going to be typing in SQL commands. When I type them in, any results will appear in the bottom half here. On the sidebar, you can see basically a folder structure for the database. So you can see we have this list of databases. I'm going to be using the AdventureWorks database, and you can see within this AdventureWorks database there are a list of the different tables, and each of these tables they have a schema to prefix a name followed by a dot and then the table name. So all of these tables are part of the sales LT schema, but they have different actual table names at the end. So the first thing to learn about SQL is how to comment in it. You'll want to comment your code so that other people can read and understand it. So there are two different ways to comment SQL. The first is to use 2 dashes, and then you can type any comment. And basically this will allow you to comment on one line. But if I was to type on another line, you can see it's a different color. That's because it's not actually commented out. The other way to comment in SQL is to use a / followed by a star. And here I can write a multi-line comment, and I can close it up with a star followed by another /. And I'll do it again. So star, multi-line comment, single line. I'm just going to follow up with a star followed by a /. So that's basics of commenting. I'm gonna write I'm gonna really focus on select queries, and I'll start to write one. And as I go through, I'll explain a bit more about the syntax of SQL as well. So the first thing I'm going to do is I'm going to tell Microsoft SQL Server Management Studios to make sure that any query that I type goes to and looks at the AdventureWorks database. So I'm going to type use and then AdventureWorks, and here you can see it's autofilled it for me. That doesn't happen on every system, but it happens here. So the command I've typed is use and then the name of the database. I'm going to close that command using a semicolon. And if I press the execute button, I won't see anything other than it saying the command's been completed successfully. But now any future commands I do where I don't specify the database will immediately just look towards the AdventureWorks database. Okay, so that's a use AdventureWorks command. The next command I'm going to make is a select command. And really, I want to have a look at the data in this product table. So I'm going to use the command select star from sales lt dot product. I'm going to close off that command with the semicolon again. Now, throughout, I'm going to just very quickly run single line queries. So if I wanted to run the whole script, I would simply press execute. But if I highlight the text and then press F5 or press execute, then I can run whatever I've selected. And here you can see I've got all the rows from that product table shown below. And you can see all the different columns: product ID, name, product number, color, and so on. And from this command, I've been able to get all of the data from that table. Now I'm going to break down what the command was. So the select statement is used to choose what columns I want to create or I want to show. So here I've done select star, which basically means select every single column that you can get from whatever whatever table is being queried. The from command, again, it's quite self-explanatory. I want to select it from this table, saleslt.product. Now, one of the cool things about SQL is that it's case insensitive. So if I wanted to type in that command using all lowercase, then I would be able to type it in and I would still get the same answer. So I'm just pressing F5 rather than clicking, just so that things pop up quicker. But yeah, as you can see, in lowercase it worked fine. I could use the SpongeBob case and I would still get the same results, because SQL doesn't actually care what case you type your command in. As you can see, yeah. Okay, I'm going to delete those because it's quite ugly to watch. Yeah, so that's the command to select everything from a particular table. If I wanted to select only a certain column, then rather than putting star in there, I would type the name of the column, which is going to be name. Actually, I'll select the product IDs first. So select product ID, and run. See, I've got a list of all the product IDs in that particular table. And now I'll try and select the name. Yeah, there you go. And now I'll try and select both of them. Now to do that, I have to basically write the names of all the columns I want to select, and put a comma in between them. So here I've got select product ID, here I've got name, from sales LT product. Now, another cool thing about SQL as a syntax is that it doesn't care about white spaces. So I could put in extra spaces in between here, and it doesn't make a difference. I can also put this command on separate lines. So what a lot of people do is they'll either have their SQL commands formatted like this, or they'll have it formatted like this, so that it's clear exactly when and where the select expression starts, or the select part of the expression starts and the from part of the expression starts. So yeah, you can see I've got the exact same answer, but I queried the language I queried the database in a different way. Another important part of the way that you write SQL is to make sure that you write your code in such a way that it's easy to read. So as well as having different parts on separate lines, you might have noticed that I tend to make the make the commands, like the actual function, like the specific commands, capital letters, and then I make any of the variables or any variables or expressions that aren't a command lowercase, and that's useful because it just makes it clearer to any reader exactly where the different parts of the statement kind of break up, and it's easy for them to differentiate the select statement from the from statement and so on. Now, another cool feature of SQL is that if I wanted to say I wanted to rename this column, so while in the database it's stored as product ID, I only want to see it as ID because I already know it's a product ID. So what I can do is I can make an alias of the name by typing product ID and then as, and then whatever I want to name that column. So here you can see it just it gives me the product ID, but the column name is now ID. And I can do the same for the table, but I'll show you that later on. But basically you can rename this table to prod, and later on you'll be able to see that it's been renamed in my results. Rather than renaming the product ID column as ID, I'm going to rename it to product space ID. So I'm going to try that now and see what happens. Immediately the command has failed. You can see the product ID has been has a red line under it, and the command failed to complete. And the reason for that is because SQL has read ID as a separate thing from product and not all as part of the alias that I want to create. So to stop that, within T-SQL, which is a language of Microsoft SQL Server, then I have to put square brackets around it. So here you see I've put square brackets around the phrase. And if I run the command again, it's worked, and now my column is named product space ID. One last thing before I move on. What you can see, I'm going to copy that command up there. You can see I've been able to select the product ID column and the name column. I can also select the product ID column, the name column, and every column by putting a star on there. And so it's selected these columns twice, which might come in useful at further points where you want to basically duplicate a column. And I can, in fact, I can select the same column multiple times just directly. There we go. Okay, so now that I know how to select what columns I want to choose from, now I'm going to show you how to select, how to do a select statement, but customize the order of your results. So I'm going to do select star from the product table. Here you can see I've got a list of all my results. Now, what if I wanted to order the results by the product ID, so that rather than having them in a random order like they are now, they would be in ascending order for that product ID. What I can do is at the bottom, below the from statement, I can say order by, and then I can type in the name of the column that I want to order by, which is product ID. And there you go. Now every single row is ordered by product ID, and you can see it's increasing as I'm scrolling down. Now, if I was to say use an alias, so I was going to turn product ID into ID, I could still use that alias to filter on the table and to not filter, sorry, to order the table. So now it's ordered by the ID. And if I wanted to, do an order by, and I tried to use the old name, let's see what happens. It still works, and that's because it understands that you want to go, you still want to order by the original column that was in the database. There we go. Now that's cool, I've got it ordered by the ID ascending order, but what if I want to order it in a descending order? What I can do is I can add to the end of this line, I can say descending, DESC, and if I run that function, you can clearly see now the results are ordered in descending order by the product ID. And if I want, I could order by multiple columns. So what if I want to order by the ID, product ID first, in descending order, and the name second? Let's try it out. So there I've got it ordered by the product ID in descending order and the name too. And as you can tell, this is in, well, let's see what order it's in. If I type ascending, I can get it to be ordered in ascending explicitly. Oops. And if I type in descending, I can get them to be ordered in descending order. And I can switch it up and have one in ascending order, one in descending order, whatever works for me. Okay, so now that I've got the orders sorted, I can say, okay, I want to select data from a table in whatever order I want. Now, I kind of want to pick, say, the top 10 IDs in descending order from this table. So to do that, I'm going to use the top command. So I'll show you it here. So select, I'm going to select everything. I'm going to select every single column, and I want it to be from the product table, and I want to order it by the product ID in descending order. But again, I only want to select the top 10 items for this particular row. So what I'm going to do is I'm going to say select top 10 ID, product ID, and all the other rows, and I want to order that in descending order. Okay, if you could cut everything that I did after I copied in top. So basically, if you go back to when it looked like this. So yeah, I want to select the top 10, and to select the top 10 from this table. And to do that, I'm going to copy and paste the old command, and I'm just going to select every single column and see what I get. And to select the top 10 rows from this table when it's ordered by product ID, I can just type select top 10, as you can see up there. And if I press F5, there you go. I've got the top 10 products when ordered by product ID in ascending order. I can also do this without having an order by, so I'll copy and paste that. And when I don't have the order by, it will just return it in whatever order it is stored in the database. Now, beyond selecting the top items or just selecting all of the items in a table, I might only want to select rows where certain conditions are met. And to do that, I will use the select statement, but I'll add in the where clause. So what I'm going to do is I'm going to select star from sales product. And I first of all show you what the table looks like again. But I only want to select the products where the color is red. So what I can do is I can say select from where, and then the color column, I'm going to say equals, in quote marks, I'm going to type red. And here you can see the only rows that I've retrieved are rows where the color is red. I can also do this for numbers. So instead of selecting where the color is red, I'm going to select where the product ID is 706. Beautiful. So as well as using the equal sign, I can do inequalities, and I can use inequalities to decide exactly what data I want to select from different rows. So again, just going to select from the product table, and I'm going to use, actually, I'm going to have a quick look at the table to see all the different rows. So what I'm going to choose is I want to select all the data where the weight is less than 1,000. So I can type where weight is less than 1,000. And again, you can see I've got the weight is less than 1,000. I can also do less than or equal to, and that works. Oops, got it the wrong way around. And obviously greater than or equal to and greater than. As well as using inequalities like this, I can also use a between function. So if I say select where weight is between 1,000 and 1,400, let's see what I get. So here I get oh yeah, I was looking at the wrong column. Yeah, so here I get all the weights where it's between 1,000 and 1,400. I was looking at the list price column there. And what I can do as well, as you noticed, I use the and function as well as a between function there. So here I can actually stack up conditions. So I want the weight to be less than or equal to 1,000, and I want the size to be less than or equal to 50. And if I run that select statement, you can see here I've got the number of I've got a number of rows where both of these conditions are met, where the weight is less than 1,000 and the size is less than 50. I can also change that to be an or statement. So rather than having having to have both conditions fulfilled, either of the conditions can be fulfilled. In fact, I won't choose. Yeah, I won't choose the size because it's having difficulties converting it to a integer. So instead, I'll only choose rows where the weight is less than 1,000 or greater than 1,300. And here you can see, again, I've got either of those conditions fulfilled in all of the rows in the results here. As well as that, I can give like a number of options for my conditions. So if I want the color to be red or black, then I can say where color is in, if I open the brackets up, I can say black and close the bracket, close the speech marks, and say red, close the speech marks there. And there you can see all of the rows that have come out in the results have color of black or red. And I can keep on going with this list. I can put as many values as I want in them, and the results will fulfill all of those conditions, or any of those conditions. As well as doing normal filtering where I'm getting an exact match or a match between exact ranges, I can also use the like functionality to get matches where it's similar to a particular phrase. So rather than having an exact match, I can use the like function to get matches where I'm doing a kind of a fuzzy match on a particular word. So if I want to get blue products, then I could just use the like function to say where color light blue. But some of them might be spelled wrong. So what I could do, if I know that some blue items have a color that's spelled like BMUE instead, I could use an underscore. And what this basically means is that there'll be one character in between B and UE, and it will match on any cases like that. I think a better example as well would be to get names that are like this one. So here I'm going to get anything that's like classic vest. Here you can see it's matched for all of the classic vest with all of the different sizes. And that's because I've used this percentage sign, which means 0 or more characters next to this particular phrase. And finally, I can also use the null value to do some matches. So as you can see, some of the weights are null, some of the cell end dates are null. So what I'm going to do here is I'm going to match all of try and get all of the rows where the weight is null. I'm going to quickly delete that. And as you can see here, every single row in my result has a null weight. I can also say is not null. And what the not statement does is it basically reverses, it finds the inverse of whatever the condition would have been. So here I'm saying anything that is not null. And I can use the not statement on, I can use not on anything like. So here I'm going to select all the rows where the name is not like classic mess. Yep, so as you can see, for all of these rows, the name isn't like classic vest, whereas for all these results, the name was like classic vest. So I've shown you a huge range of different functions that you can use with the where syntax. You can, as well as saying not, you can also say, you can also use the not equals to symbols. So that's an exclamation mark and an equal sign. here I've selected all of the rows where the name is not equal to classic vest, and I can add in extra conditions. So here I'm going to say where it's not equal to classic vest and the weight is not null. And as you can see, you can start to build up these statements and add in more complicated conditions for the matching. Be aware as well that it's useful to use BODMAS, brackets, order, divide, multiply, addition, subtraction, which is basically the order of operations. So if I wanted to use an AND statement and an OR statement, depending on where I put brackets, I would end up with different results. So here I'm going to say, I'm just going to leave it as where sold end date is null. And because of BODMAS, it will do the AND statement first, and then it will look at the OR statement. If I was to put brackets around this particular section, so I can say weight is not null or sell end date is not null, then it will look at the OR section first before looking at the AND section. So it'll say where this is true and where this is true. Beyond that, I can also get a list. I can change the select statement to get a distinct list of values or a unique list of values. So if I was to just say select size from sales lt.product, then as you can see, I just get a list of all the different products and their sizes. But if I wanted to get a distinct or a unique list of all of the different sizes, then I can change that query to say select distinct. And here now I've got, it's a lot smaller table, only 19 rows, and I have a list of all the different types of sizes that they have in that particular table. What I could also do is modify the output from this select statement. So what I'll do is I'll select the, I'm going to select the product ID, and I'm going to order by product ID. Won't put a distinct on it just to keep it simple. And what I could do is in the select statement, I could say, okay, product ID is cool, but I'm just going to add an extra one to all these product IDs. So here you can see it's 680, 706, 707, and so on. When I run this command, see it just adds one to the value 681, 707, and so on. And I can alias this as ID +1 and also show the actual product ID, as you can see there. And depending on the data types in the column, you can run a huge range of different functions and methods to manipulate the data so that your results have done some kind of calculation on whatever value is in those particular rows. Here, because it was an integer, it was quite easy for me to just say +1 or +10. But with say like strings or text fields. You can have other types of, you can do other types of manipulation to the data, and really it depends on what you have in there. So now that I've got all the select statements through, what I'm going to show you is the aggregations that you can do the aggregation calculations that you can do within a select statement as well. So like I said here, you can see I've got, I can just like add 10 to the product ID. But what if I wanted to do, to gather some statistics about all of the data? So if I wanted to filter the results so that I could only get the results where the maximum list price was greater than 100, then rather than using the where statement, which fails when you type where, say max LP greater than 100, you can see that's failed. Even if I type max list price, see it's failed again. Instead of doing that, I use the having function. So by bringing in the having function, I can write max list price greater than 100. And here you can see it's cut off the colors where the list price was less than 100, which we can get by changing that inequality around. If I was to put max LP in here, then it wouldn't work. I have to write in what the actual aggregation calculation is. Otherwise it won't know what to look at. So there we have it. And what I'm gonna do is kind of build up this statement so you can see the order that these different functions should be in. So the select part of the statement should always be at the top. The from part can come next. If I want to have a where condition in, I can put that in below. So I'm just going to say where list price is greater than 2. I obviously can't have a where condition that is unrelated to the data that I'm querying. After that, I can put the group by in, and after that, the having clause. And finally, right at the end, you can have the order by statement. So I want to order it by color. And here you have it. All of the different parts of the SQL select statement brought together so that you can run a more complicated query to select the data that you need within a database. Okay, I'm gonna pause there. So I had some more things that I could have shown, but I realize it's getting to an hour now, and the other stuff, while it's interesting, it's a little more complicated as well. I'll have to give a bit more backstory. Shall I just pass it on to the next person at this stage then?
Yeah, you can do. If you do a little just say, yeah, we're wrapping up. Obviously, there's a next session if people want to attend or something like that.
Yeah.
Yeah, that's
okay.
Fine.
Sweet. Okay, thank you all for listening. What I've really shown there is like the basic steps of a select statement, and there's a lot more to SQL. As you saw in the presentation, it's not just about querying databases. You can also do data manipulation and changing the settings and the operations within a database. All the commands that I've shown you today were done using T-SQL, which is Microsoft's SQL language. There's a little bit of variation in SQL languages across different platforms, but it is mostly the same structure and it will have mostly the same syntax. So what you might find is, for instance, rather than being able to use the top command in your version of SQL, you might have to use a limit command. Similarly, some of the other functions that I've used might have slightly different syntaxes within them. If you are interested in learning more about SQL, then please listen and watch the next video. That'll dive deeper into SQL and some of the cool features that it has. And if you have any questions or you want to get in touch with me, then feel free to add me on LinkedIn. I'm happy to talk to anyone that's interested in data and SQL. Thank you.